Hello everyone, Michael Bruno here. I'm a .NET developer working on cybersecurity related applications. Today, I'd like to impart some knowledge on you about leveraging the WPF PasswordBox User Control with MVVM design methodology. This control had me stumped for some time, so I thought I'd put together a simple tutorial about it. In legacy WinForms, the trusty old text box control has a property called passwordCar, which, if defined, replaces the characters entered by the user with repeated instances of the defined character. It obfuscates the text on screen, however, the security value of that feature ends there, as the text property of the text box still contains a plain text string. The password box control in WPF aims to provide better security by storing the entered value as a secure string object. In .NET, strings are immutable, meaning that once they are created, their value cannot be changed. It also means that strings can't be programmatically scheduled for garbage collection. They remain in memory for an indeterminate amount of time after being used. So there is a risk of their values being revealed to another process. Therefore, strings aren't a good place to store sensitive information such as passwords and credit card numbers. The secure string class provides a layer of data protection. The value of a secure string can be changed as needed within their owning process, and they can be garbage collected when no longer needed. The challenge with the password box control is that it does not expose a dependency property. That's bad for simplicity, as you can't simply bind a property from your view model to it. That's good for security, however, because allowing for standard property binding would negate the data protection provided by the secure string class. Although there is a bit more complexity involved with leveraging the password box control, this video aims to provide a simple, easy-to-follow guide which should make using the control a lot less obtuse. In this example, I'm going to create a simple WPF application which contains a single window. The window will contain a password box control and a button. The goal is for the button to trigger a dialog box to appear displaying the number of characters currently contained in the password box. I'm starting off with a WPF project which contains a single window. First, I'm going to create a view model class to act as the data context for our window. We know that we want our window to contain a button, so I'll add an iCommand property called checkPasswordLength command. I'll also define a delegate method, which will do nothing for now, and use it to instantiate our iCommand property in the view model constructor. Now I'm going to add an interface called iPasswordContainer. I'll have it inherit from iDisposable, and I'll give it a single getOnly property of type secure string we'll call password. Before I move on, let me wire up my view model with my window in XAML. While we're here, I'm going to introduce a password box control. For our purposes, the control needs a name, so I'll name it PWD entry. You'll see how this ties in a moment. I'll also add a button control, which I'll bind to our checkPasswordLength command iCommand implementation. Now I'm going to open the code behind from my main window view. I'm going to alter this class so that it implements my new iPasswordContainer interface. In order to satisfy the contract, we need to create and define the password property and implement get. We also need to implement dispose to satisfy the contract. In this method, we'll simply call dispose on our password secure string property. Now, when the application is closed, the password property will be garbage collected. Here's where things start to get interesting. Now that I've introduced a password box control in XAML and gave it a name, I can reference that object here in code behind. So get, for the password property, will return the secure password property of my password box control. The secure password property of our password box class contains the contents of the password box in the form of a secure string. Okay, let's tie everything together in our view model. It's time to define a body for our action delegate. In this case, we're actually going to use the object parameter that is required to be passed in. I'm going to define a variable named securePassword and assign it as such. I'm going to take my object parameter O and cast it as an object that implements the iPasswordContainer interface. The resulting object must contain the password property, which I will assign to my secure password variable. One last thing we need to do in the Windows XAML. We're going to add the command parameter property to our button, binding it as such. This makes it such that the command delegate method realizes that the window which is passing a parameter to it is implementing the iPasswordContainer interface. This allows us to maintain the segregation between our view model and our window. but at the same time, making our view model aware of the contract implementation. This allows our view model to access the password property from our contract. To break this down more succinctly, the relative source property sets the binding source by specifying the location relative to the position of the binding target. Here, we're passing find ancestor as the relative source and specifying the ancestor type as window, since our main window class extends the system.windows class. As a result, our view model will be made aware of the specific type of the callback object O, which gets passed into our action delegate. This allows us to access the properties from our iPasser container interface. Okay, let's debug this application and see what happens. Let me put a breakpoint in the command delegate method so that we can observe what is happening. I'll enter some characters into the password field and then click the check length button. As you can see, my secure password variable now contains the value entered in the PasswordBox control as a secure string object. This application simply displays the length of the secure string. However, now that you know how to access the property value in your view model, you can decide what to do with it from there. In some cases, you will be able to leverage the secure string object natively. However, if you find you need to access the plaintext value from your secure string property, there are plenty of examples of how to do that on Stack Overflow. Well, that's it for today. I hope I clarified the correct way to leverage the PasswordBox WPF control using MVVM methodology. I've left a link in the description to the public repo where you can find the completed project from this tutorial. If you found this tutorial to be helpful, please feel free to leave a like on this video. If you have any comments or questions, please leave a comment down below and I'll do my best to respond. You can also follow me on Twitter @PKIMike. Thanks for watching.